Good morning. I've had a little. Some of the things, the vehicles that we have fixed tend to stick in our minds more than others. You know, there's things that we see that where it looks like there were multiple failures at once, and it's almost like somebody was stacking the deck against us. And sometimes the multiple failures all have one cause, and sometimes it seems like things fail at the same time with no rhyme or reason. You might remember that 2003 Explorer I told about one time that belonged to one of the presidents of the college over there, and his daughter drove it, and it had a bunch of racket coming from the rear end. And so we used the chassis ear to isolate the, the chassis ear is kind of dicey because when you put it on there, it makes everything sound louder than it is, but you can usually pick out the really ugly sound and figure out where the preponderance of the noise is coming from. And so we clamped the microphones here, there, and yonder, and it was loud in several places, but it was loudest there at the differential. And this is one of those aluminum chunks that's bolted up in there that's got CV axles going out to the hubs. And we went ahead and pulled the differential apart, and all of the bearings in there were brindled and just in horrible shape. So we found out what was wrong with this thing, and so we went ahead and put it all back together and set up the gears like they were supposed to be, and painted it like you was painting your porch, and we turned it through, and we got the pattern right on the gears and all that. Got the preload right on the bearings, and we drove it, and it wasn't as noisy, but it still had noise. And I was thinking, what the heck? So we put the chassis ear back on it to see if maybe we had botched it up when we put the bearings in the differential. And it turned out that the preponderance of the noise had moved to the hubs. And when we went out to the hubs, both of the hub bearings were really in nasty shape too. As a matter of fact, we changed them out, the noise was gone, and I cut those bearings apart, and they were in just as bad a shape as the ones in the differential. Now, if the bearings had all been swimming in the same grease, you could probably feel like it was particulates that got in there and destroyed the bearings. But I was really interested in why it was that we had so many bearings fail at one time. Anyway, that thing was quiet when we got through with it. But this particular one here had multiple failures. It was a 2008 Nissan Maxima, and a lot of stuff, a lot of codes, and a lot of inoperative dash panel and AC functions on it. And when we went to investigating that, we found out that, and you might have seen these, this little tray right here looks like a perfect place to throw coins, but there's a little bit of a space between that screen and that little shelf, and the coins have a tendency to fall. Here's the touch screen, and when you pull this apart, there's this little very important electronic unified meter and AC amplifier box that's right underneath that screen, and facing up on that darn thing there is a see, that's the meter. Now facing up there is a hole that's just the right size for a penny or a dime to fall through. And it's funny because the Nissan mechanics for years called this thing the piggy bank. That's where the coins like to fall. Now right below that little neat shelf, and it's a perfect place for that stuff to fall through. And that's when here, shorted out some of the circuits, and it made a burn place on there. You could smell it and all that. And there's the penny that was in there. That's a smoking gun in and of itself. Don't mind the pun. All right, so the replacement part comes from Nissan with a piece of thin cloth tape over that hole. I thought that was interesting. They knew that there was a kind of a problem there, so they went ahead and did that. It's a pricey repair. Only costs pennies to generate the repair, though, so to speak. Haha. Now, Terry called me one day to tell me his '07 CRV had an inoperative AC. He dropped the Honda off a couple of days later after I told him to bring it on in, and the AC had just died on him, just quit working. Sometimes they do that. And to begin with, we turned on the AC, the air was warm, the compressor wasn't spinning. That was our two first pieces of data. See, every time we do troubleshooting, we're going to gather information, and we're going to sort it out, and we're going to see where it leads. It'll either lead us to a repair, or it will lead us to look for more data, and that's what we needed to do in this case. Now, after we identified the charge with our neutronic sniffer and connected the big machine, we pulled up about 100 psi on both gauges. That's data point number 3. So we knew that we're blowing warm air, we knew the compressor wasn't running, and we knew we had 100 psi of static pressure. Now the low pressure cutout switch should have allowed the AC compressor to kick on if it was good. Alright, so now you will not see a schematic like this on this vehicle anywhere else on the planet, because I created this yesterday. And what I typically do is I take pieces of the schematic as they're published and I actually move them around so that I can put them all on one page if at all possible. So we eliminated a refrigerant problem, and our preliminary conclusion was the compressor's failure to engage was not related to low charge pressure. I should have said to move this to the back so that S wasn't hidden right there, and I see that now. So basically we got our blower motor relay here. We've got the PCM measuring pressure here. We got the the second ECT sensor there, and there's a ground here. See, this is both a PCM. That's why they've got the dotted boxes. And so the under dash fuse relay box goes through this thermal protector, the climate control unit, and so on and so forth. You know, the climate control unit basically measures that. And there's your AC compressor clutch. And you know, the diode that's usually there is not there in this particular case. But what we're showing here is that relay right there is supposed to turn on that compressor clutch. And so, as I have talked about before, we went to find the relay. There's relays identified with snowflakes here. There's 2 of them. You're going to see that on that. See this right here? You see that? That's a fan. And this is a snowflake. These are ISO symbols, which means this is the radiator fan. This is the condenser fan. And this is a symbol for a relay. And then there's another fan relay, probably the blower, I don't know. But see how crazy they are with these hieroglyphics, and some of them you're supposed to look it up in the shop manual because they didn't know how to draw whatever it was supposed to be doing. And you know, there's a rear-winded defrost, I guess, or whatever. But the point is, this snowflake was the one we were looking for, and that's the AC clutch relay. So that's the one we went and found. And so our focus shifted to that relay right there. All right, so what we did was we put our finger on it. That's my finger right there, by the way. We put our finger on it to see if it would click. All right, and just, you know, a relay can click, and that doesn't necessarily mean that it's going to be putting the juice out. I built a relay test box one time where you could actually, it had a little light on it, and you could hook it up, plug the relay in, mash a button, and if energize the relay, if that light came on, you could at least know that it would pull some current. But that's not really a good way to go, because that relay, if it's supposed to be pulling something that's like 30 amp draw or something like that, and you just got a little 1/4 of an amp bulb that it's turning on, that's not really a good test. And I've always told my students, you cannot say a relay is good just because it clicks, because a relay can click and have partially scorched terminals that are dropping almost all the voltage that's supposed to be going through it. I was working on anti-lock brakes on a Taurus one time back in the late 80s or whenever it was, and I was made the mistake of following the trouble tree in the shop manual, which in a lot of cases the trouble tree in the shop manual is a joke, but it would lead us to these little things that say measure the voltage here, and have me measuring the voltage coming out of the relay, and they said if that was over 10 volts then you were supposed to go on with your troubleshooting. Well, I measured it and it was like 10.5 volts, which, looking at the numbers on the page, that sounded good, so I moved on. And you got to recognize this was an anti-lock brake thing, and so and it had no load on it because it was reading the 10.5 volts, but there was enough voltage drop at that relay that the 10.5 volts was not suitable to do what it needed to do when it was, whatever circuit it was turning on in the ABS module or whatever. And after I went around and around for an hour and a half fighting with that, and you know, going over every step repeatedly, I found out that relay had scorched terminals, and when I plugged in another relay, it had 12 volts and everything woke up. But that was a ridiculous bunch of nonsense whenever they try to give you a certain voltage threshold to tell you if it's above this. Now, if there's any kind of a load that relay's pulling, that little bit of voltage would have not even shown up, because it's going to drop it all if it's trying to pull any kind of a load anyway. There was a little funny side note here. My buddy Donnie, back in the day whenever a lot of mechanics didn't even have meters, I had bought one from Radio Shack, and he had bought one from Radio Shack. And my meter sometimes would wind up reading gibberish on the screen. And just for the heck of it, I pulled it apart and I saw there was this little 8-pin centipede chip in there, and there was a number on it. And I went to Radio Shack and I found out you could buy one of those little chips from Radio Shack. And so I desoldered it off the board and soldered that new chip on there and fixed my meter. And that same chip died, I don't know, about it once a year it would die. And finally I just put a little socket on there, kind of like you'd see on the old cowl packs on your GM engine controllers. And I bought a bunch of those chips because they didn't cost hardly anything. And whenever one of them crapped out, I would just plug in another chip and I'd get my meter back. But Donnie was using the meter he had that was like mine, and he was looking at a trouble tree like I'm talking about. That's what made me think of this. And the trouble tree, he says, wait a minute, this is telling me to measure ohms on a live circuit. He said, I shouldn't do this, it might damage my meter. And he was trying to decide whether to trust the book or use his own, brain to decide what to do next. And he says, wait a minute, this says to measure ohms on this while the circuit's live. I could damage my meter this way, but why would it say that in the book if that's not? It was really funny. I didn't even know what was going on, but I walked by behind him and I happened to have this little roll of bubble paper in my hand, and it just so happened that about the time he touched his meter to those 2 test points, he decided to go ahead and trust the book. I twisted that bubble paper and all the bubbles went like that. And he would, he says, he was telling me, he says, your timing was impeccable. He says, because I was just thinking damage had occurred to my meter because of that noise. It's really something. This is another example of how things come together with their timing. It makes you wonder what in the world was going on if there's some, something invisible happening there that caused them to go on at the same time. Anyway, there's your compressor clutch relay. And there's your compressor clutch. So we pulled that relay out of there and we went ahead and measured this. We got nothing. This didn't light up at all. Now I've talked about this over and over and over and over again, but this is one of the, I'm looking for a test that's going to give me the most information with the least amount of steps, and this is an example of that. So that AC compressor clutch, typically on most of these AC compressors, that ground on the other side is actually grounded right there on the compressor. In other words, you'll have a 2-wire connector plugged in there. A lot of times you'll have a 1-wire connector plugged in there. And this ground, right, like this one right here, and that ground right there is on the compressor housing. So how likely are you to have a situation where the compressor itself is not grounded? I mean, that's just not likely to happen. If you had that kind of situation, like if your engine ground was bad, you have a bunch of other problems. Anyway, so you either got a pin fit problem here where it's spread out, or you've got a broken wire here, or you've got an AC compressor clutch here. Nothing had damaged those wires. Nobody had ever been there. This vehicle had been pristine and not worked on by anybody else. You could unplug that, look at the pin, and it was in good shape. And so we had an open compressor clutch coil is what we basically had. That's how we troubleshot that. We went to went the extra mile on that. So we ordered a compressor clutch, right? So we went ahead and he got that thing in, and he was going to, we ordered a compressor. He was going to drive it until the compressor came in, and so that's what he did. And so he was going to bring it back when it was time to put the compressor on. Well, he called in the meantime, while the compressor was on order, and said his starter wouldn't operate, but everything else was normal. He was in another town about 15, 20 miles away, so there was a shop there that checked it out. Apparently he told them that we had been checking his air conditioner. He called back and he said the shop claimed we hadn't plugged the starter relay back in properly. Really? The starter relay's under here. We were working under the hood. The starter relay's up right here. And that's, basically what that looks like. The starter relay, the only reason that starter relay is there is so whenever the transmission range sensor is somewhere besides drive or neutral, the starter relay will be open. See, it's only closed. It's only allowed to close and carry the, juice to the starter when you have it in park or neutral. Otherwise, that relay is open and the starter won't work. But I call that a starter cut relay. Anyway, I thought that was sort of silly that they would tell us they didn't plug it back in right or whatever, you know, duh. So anyway, he went ahead and brought it back. So we never touched it. This is what we were talking about here. That's under the hood, and this was the relay we were fooling with. And this is where the relay is for the starter. So let's go on. All right, new compressor comes in, vehicle returns. All right, so we went ahead and pulled the old compressor off. And we put both compressors on the bench, side by side. We tested both clutch coils. And the old clutch coil was open for sure. We found that out on the bench. The new clutch coil would click. It would pull in when we applied voltage. And it was time now to install the new compressor. And so we went ahead and we put the new compressor on there, and say oil came with this compressor. That's one of the things I always need to know is, does oil come in the compressor or does it not? Sometimes it doesn't, sometimes it does. And usually the little piece of paper that comes with the compressor will tell you if there's oil in there. We replaced the desiccant bag, color that the receiver dryer. We pulled the system down for 15 minutes. We checked the specs. We juiced it up with just over a pound of the cold stuff, because that's what it called for, and from our light blue tank. All right. Now, we fired up the CRV and the AC clutch would not engage. Now, what in the Sam Hill are we supposed to think about this? This is the craziest thing. We know what we have to do at this point is we have to stop and we have to reevaluate what it is we've already done and how we arrive at the conclusion that we originally drew. Did we miss something? Okay, so we know what we knew to start with was that the clutch wasn't engaging, the coil was open. We verified the coil was open. I like to set both parts on the bench, and if I can, I like to test both parts next to one another and say, in this particular case, I showed the students. I said, this is why we're replacing this compressor, and this other one, watch it click, click, it clicked. This one wouldn't, this one would. Look at your meter. You know, we got about, what is it, 10 ohms or whatever it was over here. I don't remember what a compressor is supposed to have, but it ain't much. So we got very low ohms here. We got wide open circuit here. Anyway, we already verified all that. We basically proved our point. We had everything ready to turn on the AC, but the clutch still wasn't engaged. Now, if you put a customer out there watching you do all of this stuff that doesn't fully understand everything that's going on, he or she is going to think that you have maybe put a part on there that you didn't need, because they're saying, well, it wouldn't work before and it won't work now, so what are you trying to push on me? You know, this kind of thing. You can see how that would fall. You fall in that trap. One day, this guy that drove a vending machine truck. I mean, basically he refilled vending machines. It was like a 1-ton Ford with a big box on the back, and it came in on the hook. And for some reason, the driver of the truck came in with it, riding with the wrecker. And it was an old gas burner. I mean, it was a late 90s truck or whatever. And I went out there and I pulled the coil wire and I let it pop a spark, and it would only jump about 1/4 of an inch. You know, it needs to jump about an inch and scare the living daylights out of you if it's got enough fire to. And I said, you got a weak ignition coil here. And so I said, that's what's wrong with it. So I went and got another coil and put on there and fired the truck up, and everything's fine. And the guy says, well, I ran this truck out of gas yesterday, and we had to get gas and put in it. Did me running it out of gas damage the ignition coil? And I said, not hardly, but what you've run into is the same kind of thing that mechanics run into all the time. We fix something on one end of the car, and it's supposed to be our fault because something broke on the other end. There was a truck one time, there was this one customer that used to come over to the college and get work done on his Ranger, his 4-wheel drive Ranger. And I don't know if you're familiar with some in 4-wheel drive Rangers, but you got to have a special puller to pop that hub off so you can even get the rotor off and the bearing out of there. You know, you just about, it's got these little, I got a picture of it somewhere and I'll show it to you one of these days. But anyway, you put this little thing in it, hooks all the way around that little thing, and then you got a slide hammer and you pop it and it clicks it right off of there. But you won't get it off of there without busting it if you don't have that special tool. And that special tool costs $100. And I bought it, and I think that's the only time we ever used it. But the point is, we actually put brakes on this guy's vehicle because, and we actually, I'm trying to remember, I don't think we even had an on-car brake lathe at the time, but I said, we don't have any way of pulling this rotor off of here and machining it, so we're going to go ahead and just replace the pads like it is, and we put the pads on there. And this guy came back about 2 weeks later, and he says, I've got a noisy bearing on the right front, and it wasn't like that before y'all put those brakes on there. Really? Every single time we had ever worked on that guy's truck, he was trying to tie whatever went wrong the next time with what we had done previously to try to, but see, there was no warranty on anything we did at the college anyway. But even so, if something we did caused a problem, I would usually go back and take care of it, you know. And anyway, this guy I told the guy, I said, look, I'm tired of you coming in here trying to act like everything that goes wrong with your truck is our fault, so you just need to cut that out, or we're going to send you to a shop up the road and let you get your work done over there. And, you know, he kind of calmed down after that, but that was ridiculous. He wasn't the only customer we had like that either. But anyway, so what in the heck's going on here? Now, we discovered the clutch would engage if we bypass the AC clutch relay. And that's your two big terminals right there. Those two big terminals right there, you're basically looking for a ground on one, power on the other one. And if you jump past that, I'd take my pocket screwdriver and I'd stick it, you know, ease it. Now, you don't want to shove that in there enough so it spreads the terminal. You got to be really careful. You're just going to touch it. And so I basically took that and brought it over here, and stick my pocket screwdriver and bent it over there. This is the coil. This right here is the load carrying terminals on those little relays like that. So I bypassed it and the clutch clicked in and worked. We had actually done that previously. I didn't mention it, but we did, and it wouldn't click in before. Okay, furthermore, the relay had everything it needed to operate. We had 2 powers and 2 grounds. We had everything going. We turned on the AC, the PCM had the relay coil grounded, and there was power here, there was power going to the hot side of the coil, and the AC compressor clutch had a ground there. So when you got 2 powers and 2 grounds at a relay like that, you know if you've got everything turned on and it's supposed to be running, you know that you got everything you need right there at that relay socket. Conclusion was we had a bad relay. Now it's time for a detailed analysis. We got to backtrack. We had never checked the AC relay's integrity to begin with because we found the clutch coil open. Why check the relay? I guess we could have checked the relay just on general principle, but I was thinking, what's the point? In bench testing the clutch coil on both compressors, we verified our original diagnosis was sound. I said that earlier. But you got to recognize the fact, though, that we didn't anticipate both the relay and the clutch coil would have failed together. Makes you wonder which one of them failed first. That doesn't make any sense. Now, if the clutch coil had shorted out, it could have destroyed the relay, I guess. But it seemed like it would have blown a fuse, though. But it didn't. It was an open, it wasn't a short. All right, now this is a non-potted mechanical relay, and this is a potted relay. Now, the potted relay, I don't know, I've never cut one of these apart, but these potted relays have some electronics in them that these don't have, and I've seen these relays. I think I mentioned one time before a Nissan Altima we worked on where the blower motor would not kick on until until 5 minutes after you turned it on. In other words, you could turn it on and drive, for 5 minutes, and this in the winter times when it came in, the lady was saying that she was, freezing to death. But the blower motor, after 5 minutes, would come on. So we went in there, and the rear window defrost relay was the same kind of relay. And so we pulled the blower motor relay out, and we put the rear window defrost relay in that same spot. And it was, it worked perfectly. I mean, the first time you turned it on. The guy that did that job went to work at the Nissan dealership, and he says he ran into one of those, and it didn't even take him 10 minutes to figure out what was wrong, and the service manager was real impressed with that because he had already seen it one time. It was apparently, but these potted relays, what I was getting at is, and that relay there, if you got one on something like a Nissan, I like to use the Nissan relay rather than just guessing and sticking another relay in there and seeing if that will work, because sometimes you can destroy stuff like that. This potted relay right here, they do crazy things and die in peculiar ways that you may not see on a non-potted mechanical relay. Typically, if one of these relays ever closes, it's going to carry the load until the next time it closes. That's not always the case. Sometimes one of these relays can fail while it's carrying the load. It can get, I've seen that happen, but not very often. Usually if they close, you're good until the next time they close and they don't work. And all that. So, would it be too far out to wonder if the shop who checked the starter relay might have swapped the starter relay with the AC relay? because they were the same relay as far as I knew. What are the chances they would pick that particular relay from the underhood box when they were working in the underdash box? Now that doesn't make any sense either, but some mysteries aren't worth solving. You know, suffice to say, now, I mean, his starter worked and his AC worked when he left, and that was a good thing. The replacement relay from Advanced Auto Parts closed the deal on that one. No test this time, but I really appreciate you guys stopping by, and I will talk to you all next time.